Hey, welcome back. This is Dan the Dev from Learn Agile Practices, and this is our weekly Pomodoro 25 minutes together to speak about topics related to software development, agile practices on software development, technical excellence, etc. So, here we are today with a new topic, and today we will talk about microservices. My take on microservices today will mostly be related around when it makes sense to use microservices and a piece of knowledge that most people don't consider when they think about when it makes sense to use microservices, in my opinion, of course. So we will explore when I believe that microservices is a good idea also for simple or small companies, why microservices have anyways some trade-off. We will discuss about that a while. So now to finish the intro, remember to support my work. So subscribe, share the episode. Feel free to also go in the description because you find all the link to Learn Agile Practices and all the content. You have the blog, the newsletter, and everything. And you can also check my TDD email course. That is the best entry point you can find online around test-driven development. Now we can start. Okay, so microservices have been quite a big topic in the latest year, and at some point it seemed that everything should have been a microservice. There was so much buzz around the microservice idea and micro frontend that everyone thought that microservices was the way to go. Then, of course, that's not true because with microservices, we're not removing complexity. We're not even adding complexity. We're just moving complexity. We're not removing and deleting complexity, but we're moving the complexity. What I mean is that microservices, from the code base point of view, simplify things because you can, instead of having one big project that does a lot of things, you can have multiple smaller projects, and every project is simpler, right? Because they do just a small, tiny, or a bit bigger, but still a piece of the behavior that before was just part of the bigger system and the bigger code base. So you can simplify the code base by splitting them. Then you can also simplify the system by having different systems, or with micro frontend or other approaches, you can also have one system from the customer point of view, but behind the curtain you have microservices to make it work. But you're moving the complexity because the complexity goes in the way microservices communicate, right? You have to make them communicate. You have to share data, share information, share behavior between microservices probably. So you are moving the complexity from having a big code base that needs to live together to having smaller, easier to maintain code base, but they need to communicate. But one thing that we need to consider when we think about this change and shift of complexity is that when we have one big project, one monolith, we have a custom complexity. What I mean is that the complexity we have is more at a lower level within the code. So we will have to face with it while we work on our core logic and core behavior. So in our core behavior, we will have to take care in a maybe custom way or still standard, but more close to the code we need to write to handle the communication. Even if we are very, very good and we create a modular monolith, which is the new buzzword in the microservices discussion, still those modules need to communicate and you need to a way to make them communicate, and unless you go and find similar solution to the way to make microservices communicate, it will be at a class or lower, or anyway code level, lower level code. So you have to find ways to make them communicate in a safe way. But instead, when we have microservices, communication is a problem because you have the network potentially in the middle, but it's a standard problem that every company has. Is the same problem you also have when you need to interact with a third-party API, for example. So it's still a problem, but it's a standard problem, so it's easier to apply standard solutions. That's why, yeah, it's true that there is still complexity, but if I can favor standard complexity to custom complexity, well, it's easier to solve it, or at least to apply standard solutions. And the reality is, communication between tools is a solved problem. We need to only take care of one thing, an important thing, a hard, complex one, but still only this, which is that if we go for the microservices path, we need to know that microservices means that service one doesn't have to depend on service two. What I mean is that maybe service one needs some data or some information, or need to delegate some behavior to service two, which is good, but it should be always done in asynchronous. It should never depend on the fact that the service two is live. If service two is not working, service one needs to work. Otherwise, this is just a distributed monolith, as people named it, and that's the real problem. That's a bigger problem than having a monolith, and that's a bigger problem than having microservices. So that's what we want to avoid, right? If we go with microservices, service one and service two may work together, but they need to do it in a way that allows service one to work when service two is down, and vice versa. Most people connect this idea with the idea of events or event sourcing even, but actually you can just have also a cache strategy. So not in every situation you need to. It's a problem if you don't have an answer now. Maybe sometimes it's fine if you use data from 1 hour ago, for example, or 1 day ago, because it's data that doesn't change much. Or maybe sometimes it's okay if you just put your request in a queue, and then once the system becomes available or is able to handle it, takes directly from the queue. It depends, but you have to work in a way that your system, your microservice doesn't depend on the others. Okay, so that's one way. You can just cache an HTTP request that gets updated every 5 minutes, 15 minutes, 1 hour, whatever, when it makes sense. But then you have local data to serve to the front end or to your service, which is just for read, of course. So it's not data that you have to change locally. When you need to change, you need to ask the service to do changes or to do something. And in that case, probably having a queue, a shared queue, is a good idea, because you can queue the request, and then the other service can just read from that, and it can be via events, which is an easy solution. While event sourcing is not. So event sourcing is something that you need to implement only when it makes sense, because it's very, very complex, and because you have all the history of your events, and you can rebuild the exact time in the history of your system at any time. So it's something that, in my opinion, only in certain situations makes sense, where you need a lot of security, a lot of data heaviness Data is very important for your business, very special situation. But events are easy. You just, instead of directly asking the service to do something with an HTTP request, you handle it asynchronously. So you save in a, for example, you can save in a local queue that you need to make this request. Then you can have a save strategy to send this to a shared queue or to make your queue accessible, and then the other service can read the queue and execute what has been asked. So eventual consistency is something that usually we think that is not acceptable, but 99% of time is totally fine. Having data updated in a minute instead of instantly usually is a better trade-off than having a slow application or risking that we have microservices depending from each other. So we need to embrace eventual consistency. But even if we go in this direction, still people can normally think that microservices are too complex, and they suggest you to be wise and take it slow to go in microservices. Most people today think that startups need to start from monolith, which makes absolutely sense. But then they suggest that at some point you might use microservices when the complexity justify it. The point is that we usually think to complexity as technical complexity. What most people don't consider, in my opinion, or at least I see that not enough people talk about this, is that there is also business complexity. If I have, and we need to talk about domain-driven design here necessarily, we need at least strategic domain-driven design, so high-level understanding of our business from domain-driven design perspective, because as soon as we identify two bounded contexts in our companies, so two different contexts that need to serve different purpose in our companies, it's pretty clear, and that in that case, it makes sense to have two different services. So two microservices, one dedicated to bounded context 1 and one dedicated to bounded context 2. And in this case, I don't think that we are complicating things with no reason. I think that it's the best way to handle bounded context. Why? Because of course you can handle different bounded context in a modular monolith, and every module might be context in that case. But it's not just about organizing my software so that it represent the context. It's also about, when I implement a domain-driven design strategic approach, I want to keep a bounded context isolated. I want to be able to work on a context just on that, isolated from the others, release that in a safe way without risking to break the others, etc. So having it in the same repository, the same pipeline, the same place makes this a bit harder, in my opinion. Of course, you might have a subrepo for every, you can have a monorepo approach, and you can have some subrepo, one for each bounded context. But this is, at that point, the monorepo might or might not be useful in that moment, but you're actually splitting repositories, right? So you will have a monorepo that allow you to work on the subrepos. It's actually doing what I'm suggesting here. So having a physical separation, so different repositories, then you can add a layer above that puts them all together and call it monorepo, but still you are physically separating them. And so I strongly believe this, because I think that keeping those services separated, which is very important when we talk about bounded context, because the whole point of identifying a bounded context is to say that, for example, in an e-commerce, a product in one bounded context could be something different from the product in the second bounded context. So we want to keep these strongly separated. So you can achieve that with a product in the cart bounded context and one in the shop bounded context, but still you need to be careful to not mix things, etc. So I think that again, the physical separation can help from the code point of view, readability point of view, but still also from the communication, because if I create some sort of dependency from these two modules, and this dependency is coupling too much of the two modules, it will be a problem. So I mean, if I have some people usually reply to this by saying that we can have modules and then we can make them communicate asynchronously. Yes, you can do it, but then I don't see the point of not separating the repositories. It's just easier in my mind to identify one bounded context, one service. So I don't think that's a problem, and you're still going with async. So maybe in some situation, of course, it can be cost effective because you only have one system. It depends on the point, but it is not even true sometimes because it depends on the needs of the bounded context. Usually, what happens is one bounded context needs something strong, and the other one needs something very something maybe small. So sometimes you can optimize by splitting, because you can push the one that needs to be pushed and keep the other one to the minimum. That's something I've seen a lot of time. If you keep only one system, you need to push it on, even if only one of your bounded contexts need to be pushed to the limit, right, of the performances, for example. So it's the same idea of CQRS. If you don't use CQRS, you don't split the way you read from the way you write, and you need to scale because you need to read a lot or write a lot. You make one scale for the place where you both write and read, but maybe you need to scale only for the write side, because the read side is not doesn't need to have more scaling, and the performance was good. But you can only scale both because they are together. If you split them, you can have a different strategy and have, for example, a very simple and lightweight write side when you don't need to write a lot, but a very powerful and efficient read side because you need to read a lot of data. It's the same here. In my opinion, you can scale the context differently, and the more we keep them separated in my head, the easier it is to keep them isolated, which is fundamental. It's fundamental. And that's why I believe that keeping them separated physically, it helps. And I can also tell you that I did this in a small team. We had 3 bounded contexts, at least the 3 that we was sure of, because there was probably more. But we was building a B2B food delivery service. So we had the marketplace, let's say, where we was selling the products and allowing for the customers to order their lunch. Then we also needed a way back office to set up all the restaurants and products available, the food available. So we had the back office, which can be a completely different bounded context potentially. But in that case, we kept them together for legacy code reason, basically. Then we had a portal for the kitchens, for example, for the restaurants, where they could access, see their orders, and also the system was automatically providing the printers in the restaurant with the data so that the printers automatically print the orders that they was receiving, and the kitchen knows when and what to cook and to prepare for the delivery. That's another example. And then we had the smart fridges, so we had a different service to take care of the products available in the smart fridges, the payments, etc. So there was different bounded context. And we was a small team in a small startup, and I don't regret the decision because it actually speed us up. And for example, the printers in the kitchens are not, you can't trust them. It's a very unstable system that sometimes just it works by continuous ping to an endpoint you need to expose. So this is of course heavy, and I didn't want, for example, that for some reason they was pinging too much the same endpoint and causing problems to the application. I want to keep it separated. We needed just a small amount of data, so we created a read-only data pre-calculated to provide the printers with the data they need. So we was able to scale it and keep it simple. It was simplifying us, and the only thing we had to take care is that the communication was asynchronous via events and a queue that was handling the events. And every event had multiple listener based on who was listening. For example, when you put an order, you had a listener for the kitchen to show the order, a listener for the printer to build the print data to make the printer work and provide the kitchen with the printing paper. And then you also have an event from the customer service tool, for example, that noticed that an order arrived and collected all the data so that our customer service was able to provide information and support the customer effectively. Doing this in different systems helped us, because every time we had a need for a specific bounded context, they was so easily separated that it was easy to evolve there and do what they need without a real dependency with the other. So achieving this in a single system would have been possible, probably, but I feel it's harder, because writing clean code, maintainable code is already hard, and it's a problem that is not solved as much as it is solved to, for example, make two systems communicate via HTTP request or events, etc. So if I can move some complexity from writing maintainable code on a bigger code base to make some systems communicate, in my opinion, I'm gaining some complexity, because I am moving some complexity from a custom problem, potentially custom problem, to a standard problem, as I said at the beginning. And this is not removing complexity, but it is removing cognitive load. I don't have to think about how to make those services communicate. I just go for a standard solution. And if I'm using a framework, I probably already have almost everything implemented, and I just need to use it. So this is helping. This was helpful a lot. And we wasn't scientists, we wasn't superstar, rockstar developers, just average developers that was trying to do their best. So as I said, it's a decision that I never regret. So this is a huge feedback for me, but I also saw it in previous experiences where I wasn't leading the decisions. So I strongly believe that most people should consider bounded context when they think about microservices, because that's a very good reason to have a microservice. Then within the bounded context, you can, the decision of having even smaller microservices or micro front end is based on different things, more technical things. So it's up to the team, in my opinion. But when it's related to a bounded context, it makes a lot of sense in that case, because in my opinion, it makes it easier to keep them independent from each other. That was my take today on microservices. So I hope the episode was interesting for you. Let me know what you think. You always have multiple ways to let me know. You can just email me. You can just add me on LinkedIn and text me on LinkedIn, or you can use the comments in the LinkedIn post where I share the episode, or you can join the Telegram channel where I share everything I publish, and you can use the comments to share your thoughts with the community. Thanks, everyone. We are done also this week with the weekly Pomodoro, and see you next week. Until next time, happy coding.